Hello friends, welcome back. In previous video we started evaluation of double and triple integrals with direct limits. So I wish to solve one more problem on this. So with respect to double integration, so let me consider the fourth example. Evaluate. The problem is integral 0 to 2 integral 0 to x e power x plus y into dy into dx. So given, let's see its solution. Given integral I is equals to integral 0 to 2 integral 0 to x, function is e power x plus y into dy into dx. So this is the given problem. Let us identify the limits first. So here first integral limits are from 0 to 2 and second integral limits are from 0 to x. So 0 to 2 is 0 to 2 are the constant limits and 0 to x, here upper limit is x, therefore it is variable limit. So when they are giving variable limit, you identify the order on the basis of this. Okay, 0 to x, 0 to x, the limits are in terms of x, means of course the limits of y. So y lower limit is 0, y upper limit is x, and in the same way the remaining x lower limit is 0 and x upper limit is 2. Now let me integrate. I equals to integral 0 to 2 integral 0 to x e power x plus y into dy into dx. So order of integration is first with respect to y, then with respect to x, because your variable limits are related to y. Therefore first you are integrating with respect to x, then with respect to y. Next, in next step, integral 0 to 2 integral 0 to x e power x plus y, you can split it as e power x into e power y into dy into dx. So I is equals to integral 0 to 2, here we are integrating with respect to y, therefore e power x is constant and e power y integration is e power y itself. Limits are from 0 to x into dx. Now let us apply the limit. So e power x is constant, integral 0 to 2 e power x is constant. In place of y you are keeping upper limit x and 0, therefore e power y, in place of y you are keeping upper limit x minus e power 0. So e power x is related to the upper limit x, e power 0 means it is from, we are writing from lower limit 0. So into dx. I is equals to integral 0 to 2. So e power, if you multiply e power x into e power x gives e power 2x minus e power 0 value is 1, 1 into e power x is e power x into dx. Now let's integrate finally with respect to x. I is equals to integration of e power 2x gives e power 2x divided by 2 minus integration of e power x is e power x itself, and the limits are from 0 to 2. So upper limit of x is 2 and the lower limit of x is 0. Therefore I is equals to 1 by 2 is constant. In place of x you are using the upper limit one time and lower limit next time. So e power x means in place of x if you put 2, you are getting e power 4 minus e power 0. Okay, minus again in second term if you use the limits e power 2 minus e power 0. So I is equals to, so if you simplify, you are getting e power 4 by 2 minus e power 0 is 1, therefore 1 by 2 minus e power 2 minus 1. So you are getting e power 4 by 2 minus 1 by 2 minus e square minus, okay, sorry, here minus sign is there now, minus into minus becomes plus, here plus 1 you are getting. Then in next step, if you take 1 by 2 as common, then you are getting e power 4 minus 2 e square plus 2, sorry, plus 1, here 1. So you can rewrite this as I is equals to 1 by 2 into e square minus 1 whole square, that is a minus b whole square format you can write. So this is the answer for the problem. And the next problem, so I will consider triple integral problem. Evaluate. So first integral limits are from 0 to 1, second integral limits from 0 to 2, and third integral limits from 1 to 2, and the given function is x square yz into dx dy dz. See, it is related to 3 variables, right? So then the evaluation procedure is same as double integral. Here also you need to focus on the limits. So if you focus on the limits, integral, first integral limits are from 0 to 1, second from 0 to 2, and third is from 1 to 2. So all the limits are constant limits. Therefore you are going to choose the order on the basis of this. Okay, so first they are given dx dy dz. It means first we are integrating with respect to x, then with respect to y, then with respect to z. Okay, this is the order of integration. So now let's integrate. So given I is equals to first integral 0 to 1. Here if you identify the limits, order of integration is x, y, z. Then accordingly 1 to 2 are your x limits, and 0 to 2 are y limits, and 0 to 1 are z limits. Okay. Then second integral also you write as it is, integral from 0 to 2, and the third integral is with respect to x, that is integrals limits 1 to 2, function x square yz into dx then dy dz. So I is equals to first integral 0 to 1, second integral 0 to 2. Then this function, if you integrate with respect to x, x means the remaining variables you are treating as a constant. Here the function is x square yz, function is x square yz. Here yz you are treating as a constant, you are going to integrate only with respect to x. Okay, therefore yz is constant, you write at one place. Then x square integration gives x cube by 3. Okay, for x cube by 3 you are going to use the limits 1 and 2. Okay, close the bracket, into dy into dz. In next step, I is equals to integral 0 to 1, integral 0 to 2, yz by 3 is constant. In place of x cube, if you use upper limit and lower limits, so first of all let us use the upper limit 2 in place of x. It gives 2 cube minus lower limit is 1. So 1 means we are writing it as 1 cube into dy into dz. So let's simplify this. I is equals to integral 0 to 1, integral 0 to 2 yz by 3, 2 cube is 8 minus 1 cube is 1 into dy into dz. Therefore, I is equals to integral 0 to 1, integral 0 to 2, 8 minus 1 gives 7. You can write it as 7 yz divided by 3 into dy into dz. So, our next target is we need to integrate with respect to y. Okay. So, I is equals to, we can rewrite this expression as integral 0 to 1 within the bracket integral 0 to 2 function is 7 yz by 3 into dy close the bracket into dz. Now, let us integrate with respect to y. Integral 0 to 1 with respect to y means 7z by 3, you treat it as a constant. So, y integration gives y square by 2. So, y square by 2 limits are from 0 to 2 into dz. So, therefore, I is equals to integral 0 to 1 7z divided by, in denominator 2 is there now, if you multiply 3 into 2 you are getting 6, and in place of y square you are going to use upper and lower limits. So, your upper limit of y is 2 and lower limit of y is 0. Therefore, you can write it as 2 square minus 0 into dz. So, if you simplify this, I is equals to integral 0 to 1. So, here 2 square gives 4. So, 4 into 7. So, 4 into 7 gives 28 by 6 into z. Z into dz. Now, let us integrate with respect to z. So, 28 by 6 is constant. So, integration of z gives z square by 2 and the limits are from 0 to 1. So, I is equals to 28 by 6 into 2 is 12. So, in place of z square, if we use upper limit 1 square gives 1 minus lower limit is 0. So, finally, if you simplify this expression, 28 by 12 gives I equals to 14 by 6. So, this is the answer of your triple integral. Okay. So, now if in case if they are giving variable limits, so how to solve the problems related to triple integrals. So, let me explain briefly. Suppose the given integral limits are from 0 to a, 0 to x and 0 to y. Function is x, y, z into dz, dy, dx. Suppose in case if they are asking triple integrals with respect to variable limits, then how to identify the limits and evaluation procedure. So, if you see, because we need to proceed with order of integration, if you look at the first integral limits are from 0 to a, it means constant limits, and second integral limits are from 0 to x and third integral from 0 to y. So, always in previous cases we have seen that if they are given in terms of x means y limits, y means x limits, that is in case of double integrals. So, in the same way here in triple integrals, 0 to x means these are the limits of y, 0 to y means z limits and the remaining is x limits. So, therefore, 0 to a is x limits, second integral is 0 to x. So, it is in terms of x means you are identifying as y limits. So, 0 to y, it is in terms of y means it is z limits. So, it is like almost rotation basis. So if there are three variables, means of course if they are giving in terms of x means y limits, if they are giving in terms of y means z limits, if they are giving in terms of z means x limits. So this is like a rotational order. Okay, so this is the identification. So then on the basis of this only you need to integrate. So your integral, your inner integral limits are with respect to z. Therefore first you need to integrate with respect to z, then with respect to y, then with respect to z. Sorry, this is x. So this is the order of integration. So first is with respect to z you are integrating, because the reason is your innermost integral is related to the variable, so related to the variable z. Therefore first you are integrating with respect to z, then your second integral limits are with respect to y. Therefore you are integrating with respect to y, then with respect to x. So you follow this order of integration and integrate the given functions and apply the limits as usual, so you are getting the answers. Okay, so this is the procedure of evaluation of double and triple integrals when they are giving limits. So you need to think only about order of integration, because order of integration we are going to choose whether they are giving direct constant limits or variable limits. If they are giving constant limits, then look at the given variables and decide the order of integration. If the variables are if they are giving variable limits, then you look at the first integral, means the innermost integral is related to which variable. So you start the integration process from that onwards. Okay, so thank you for watching the video. So in my next video I am going to tell you integration, evaluation of integration when they are not giving direct limits. Okay, thank you for watching.